In this video, we're going to go over the Autosave step and the native SoundCheck format. When a sequence runs, all data that is output is saved to memory. This is accessed through the memory list in SoundCheck. If you want to save to disk directly in a sequence, use an Autosave step. This will take the data from memory and save it to disk. Otherwise, if SoundCheck gets closed or the computer gets turned off, data will be cleared from memory. These autosave steps must follow the steps that create the data. For example, if I want to save my fundamental, it must come after my analysis step that creates my fundamental in the sequence. To change what you're saving, the location of the file on disk, the format and the naming, we use the Autosave Editor. In the Autosave Editor, we choose what we want to save with these radio buttons on the left. If we select data, it will save curves and values, results will save results, and waveforms will save waveforms. As we select different options, the data in the table will change. Only one type of data can be saved per autosave step. If I wanted to save results and waveforms, I would need two autosave steps. We can control or shift-click to highlight multiple pieces of data to be saved. In this example, I held Control while clicking to select Fundamental, THD Normalized, and THD. We can also choose where the data is saved to disk in the folder path. Right now, Use Default is enabled, so it will be saved to my Data folder in my SoundCheck 17 folder. I can change my default and edit preferences, or if I disable default, I can save to anywhere on disk, either using an absolute or relative path. Here is a list of the data types and what format they can be saved in SoundCheck. Now let's jump over to SoundCheck and take a look at when we'd want to use an autosave step. I'm going to open up an example sequence called Complete Test with Amp Connect. This is a loudspeaker test that I'll be using throughout these videos. When I run the sequence, it populates these graphs with all of my data. If we look at the memory list, by going to Setup Memory List, we can see all of this data is completely filled. But again, all of this is just saved to the computer memory. If I run the test again, everything I ran from the first test is completely overwritten. Or if I close the sequence, all of my data is now gone. So what we want to do here is add an autosave step. When the sequence is run, it will take the data from memory and save it to disk. That way it can be opened later in SoundCheck or any other program I want. I'll choose the Save to DAT Overwrite template and drop it at the end of the sequence. Remember, the data must exist before the autosave step, so autosave is usually one of the last steps in the sequence. At the top, there's options to select the data results and waveforms, and then this table to the right will reflect what option we have selected. I'm going to open up the memory list, and we can look through the curves and the values tabs, and we'll see that they match up one-to-one. If I selected results, it would match up with my results tab, and if I selected waveforms, it would match up with my WFM tab. I'm going to select some pieces of data from the right here that I want saved to disk. If I hold Control, I can select multiple pieces. And if I hold Shift, I'll select all pieces between the two clicks. I'm going to select a couple of pieces of data here: the fundamental, THD, rub and buzz, impedance, and average sensitivity. My format is set to SoundCheck, and my autosave folder path is set to Use Default. So when I click Apply here, that data will be saved onto disk at that location. We'll see a file called Complete Test using Amp Connect and today's date. If I close my sequence, the data stored in memory is gone. However, I could select Data, Open Data, and open up that file that I saved to disk. In my Curves and Values tabs, the data that I saved in the Autosave Editor is now opened up back in SoundCheck. I'm going to delete the data from memory. This won't affect what is saved to disk. I just want to clean up my memory list for the next run. If I disable Use Default, I can click on this Browse button and point to anywhere on disk that I want the file to be saved. Instead of clicking Browse, you can also type in a file path. A blank file path will save the data in the same folder that the sequence is in. You can see here I am in SoundCheck 17, Sequences, Loudspeakers. If I open up that directory, here is my saved data. If I type folder in here, it would save in C, SoundCheck 17, Sequences, Loudspeakers, and create a directory called folder. To add in another directory, separate them by a backslash. The SoundCheck format has different file types per what we have selected up here at the top. Data will be appended by a .dat, results with an res, and waveforms with a wfm. I'm going to set this back to default and save results. Now when I look at this folder, we'll have two files with the same name with different extensions. One holds my results, one holds my data. So if I wanted to save both data and results, I would create two autosave steps. I'll rename this one and save the results. Then drop in another one to save my data. Now let's look at some of the options we have enabled. You can see some of this area here is grayed out. That means when we have the SoundCheck format selected, none of these options are applicable. Below, we can add the test information. We can choose to save the operator, the time, lot number, serial number, or prompt the operator for a comment. This data is saved inside of the file and is not affecting the name of the file that is saved to disk. On our last run, serial number was selected. You can see serial number is appended to the data name. The serial number is blank, so that's why it's showing up with nothing after it. If I uncheck serial number and applied the autosave step, my file name is set to new/overwrite, so that means it will overwrite the existing DAT file that does contain the serial number. I want to always replace it without prompting, so I'll enable that checkbox and click Yes. Now if I go to the memory list and open that data again, my values and curves will no longer have a serial number. I'll enable everything, add in a lot and serial number, and run the sequence again. Here is the prompt for comment option. I'll delete everything in the memory list, open up the DAT file, and expand the memory list so we can see. So here next to average sensitivity, you can see all the test information that was added. We'll open this step up and take a look at the file name section. This section changes the name of what's saved to disk, not the information inside of it. If I switch this from new overwrite to append, every time I run this autosave step, it will keep adding to the same exact file. Here is where we construct the name. So right now it is sequence space date, which is why the name of the file on disk was complete test using AmpConnect with today's date. So I'll just run this sequence a couple more times. I'll delete the data that I had saved before, and then open up that same file. you can see there's multiple pieces of data saved from each of those runs. The biggest benefit to saving in the SoundCheck format is how easily it can be brought into SoundCheck for further data manipulation or viewing. It remembers the X and Y units, so if we look at these fundamentals, it knows that the Y-axis, for example, was measured in dB SPL. So say I wanted to change the actual name of the file saved to disk. Here in the right under Template is what the name of the file currently is, and the separator is what will separate all items in the template. To change the name, we can change the parameters here in the Construction tab. If I click Clear, it won't have a name. I can cycle through this Construction tab, select Items, and click Add to make different names. If I select User Defined, I have a box down here to specify a user-defined piece of data. So if I ran this sequence, for example, it would be saved with a lot number, space, user-defined, which I'll define as SQC, and then I'll add on if it is a data, result, or waveform. And I'm going to turn off prompt for comment to save some time in the future. I run the test a few times, and now we see my lot number, which was 1234, space, the user-defined SQC, space, data. Every run of this lot number is now being saved to the same file on disk. If I change the lot number and run the test, you can see it creates a completely new piece of data. This data name construction can be really important for how you want data to be saved. For example, if in the file name construction you had serial number or time, you might have a lot of pieces of data saved to disk, so your folders can become a little bit crowded. However, if you saved all the data to just one DAT file, that one DAT file could become extremely large and unwieldy. A good middle ground is to save the file with either the lot number or the date. This makes it easy to find any test that was ran in a specific lot or a specific day without having a ton of pieces of data saved to disk, or vice versa, having a ton of pieces of data saved into a single file. Another option we can have here is to select a memoryless value. Now my data file will be the time, a memoryless value, as well as the user name. And now I'll just change the separator from space to underscore just to see the difference. Now I run the sequence, and I see those pieces of data. It will show you the time, underscore, my sensitivity level, and then who ran the test, which was the operator named Mark. You can see for every time, we're going to be getting a new file on disk, and then it's going to be showing us what the average sensitivity was for that run. There's a couple of different ways that this can be really helpful. One example might be if you're using a loudspeaker on a turntable, so you could have one file with everything at 0 degrees, one file with everything at 10 degrees, etc. Something like this will just give you a quick overview of what the sensitivity at 1K is. Another option is to turn off automatic naming altogether. Now whenever the step runs, it will just open up Explorer and ask you to point to where you want the data saved and how you want to save it. So here, if I just type in blah blah as my name in my data folder, we'll save a DAT file called blah blah. One of the major benefits of saving waveforms in the SoundCheck proprietary format and not in waves is that if you bring the data back in, all of the calibration and metadata is saved with these files. You can run analysis or post-processing steps and get meaningful data out of these waveforms. I'll just open up a heterodyne analysis step, point to the waveform I have saved. I output a fundamental curve from that waveform. We can even add in tests that we didn't run in the first place. In the next video, we're going to go over configuring a database to run with SoundCheck.